Alright guys, so this is the video for section 9.5, and in this section we're going to be learning how to graph the parent function of tangent of x. Okay, now we're not going to go nearly as far with tangent as we did with sine and cosine, and so this should be a little bit more simple than that, especially if you can learn what the parent function looks like. Okay, so kind of what we're going to do at first is we're going to kind of find what the parent function y equals tangent of x looks like. Okay, so real quick, I want you to go ahead and pause this video and put these in your calculator. Make sure you're in radian mode. Okay, so make sure you're in radian mode, and I want you to find the y value when of the tangent of negative pi over 2. And for the tangent of negative pi over 3, and so on and so forth. Okay, so go ahead, put each of these into your calculator, make sure you're in radian mode, and fill out this table real quick. Alright, so what you should have gotten looks like this. Now, one of the things that probably jumped out at you is you have a few of these that were undefined. Okay, so remember that tangent is equal to sine over cosine. Right? So basically what we did is any times cosine is negative, tangent will be undefined. Okay? And when tangent is undefined, think of what that looks graphically. That means we have an asymptote. Okay? We've talked a lot about asymptotes in the past, but if you don't know what an asymptote is, please go ahead and look that up. Just Google it real quick, and you should understand it. All right, so we have an asymptote when tangent is negative pi over 2. So I'm going to go ahead and negative pi over 2. That's my asymptote. Remember asymptotes, it's going to get really, really close but not cross at pi over 2, and then also at 3 pi over 2. Okay, and I'm just going to do this real quick because it's really hard to graph on these slates. But what happens is we cross our midline, in this case it's the x-axis, right here, and these are asymptotes. So we get closer and closer and closer and closer, but we never touch. And we get closer and closer and closer and closer and closer, but we never touch. Okay, and then we repeat that again. So we get closer and closer and closer and closer and closer, but we never touch. And then closer and closer and closer and closer, but we never touch. Okay, so this is what the parent function of tangent looks like, and just like sine and cosine, we can continue drawing these periods, and they would be the same, the same, the same, the same. So this would just repeat its pattern over and over and over. All right, so let's look at some characteristics of tangent. Now, this is tangent and cotangent. We are actually not going to worry about cotangent. So we can X that out. We can also X this out here. And then we can X the very last part out. We are not going to touch cotangent. We're only going to worry about tangent. Okay? So the domain here is going to be all real numbers except odd multiples of pi over 2. So that would be like pi over 2, 3 pi over 2, 5 pi over 2, and so on and so forth. Okay, and if these are the values that we would have vertical asymptotes. Okay, that's where we're undefined. Okay, so the range, now remember range is our y value. We go all the way down to negative infinity, all the way up to positive infinity when it comes to y values. So our range would be all real numbers. There's no restrictions on our range. Okay, the period for the parent function, okay, this is different than sine and cosine. The period is pi. Okay, and then the x-intercepts would be plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, and so on and so forth. All right, just a few more things. Once again, we're not doing cotangent. So when we're finding our b value, okay, remember sine and cosine, it was 2 pi over b? Well, because our period for tangent is just pi, we would find our b value as pi over the absolute value of b. Okay, so if we want to find, if we know our period, we want to find our b, we would use this. Or if we know our b and want to find our period, we would also use this. Okay, now the equation to find the vertical asymptotes would be pi over 2b. Okay, And then once again, we're not doing cotangent, so we can just X these out. So really, these are the two things you need to remember. All right, so let's look at example 1A. It says graph two periods, so I'm not going to graph all the way across. I only need to graph two periods, okay, of g of x equals 2 times tangent of 3x. Okay, describe the graph of g as a transformation. Let's do that first. Okay, so as a transformation, this 2 tells us we have a vertical stretch by a scale factor of 2. And then this 3 says we have a horizontal shrink by a scale factor of 1/3. Okay. All right, so now let's use this 3, this is our b value, to find our period, right? So the period equals pi over absolute value of b. So this would just be pi over 3 is our period. Okay, so before we repeat, our period is pi over 3. Now the vertical asymptotes is pi over 2 times the absolute value of b, which is pi over 2 times 3, which is pi over 6. Okay, so this would be pi over 6. Okay, now we'd have pi over 6. Okay, remember, it's every odd one, so it would also be 3 pi over 6, which is just pi over 2, and also 5 pi over 6, and also 7 pi over 6, and so on and so forth. Okay, all right, so let's start here. Our first asymptote is pi over 6, so let's go ahead and label this. This is pi over 6. This is, I'm going to say 2 pi over 6. I know that reduces. I'm just being lazy. This is 3 pi over 6, which also reduces. 4 pi over 6, 5 pi over 6, and 6 pi over 6. Okay, so I'm first going to draw my vertical asymptote. So I have a vertical asymptote right here. And then I have a vertical asymptote right here. Okay, and then I have a vertical asymptote right here. Okay, and I can keep going if I want, but I don't have to. I only need 2 periods, and here's 1 period, and here's 2 period. Okay, so basically the asymptotes are halfway before where this crosses the midline and halfway after. Okay, so if the period's pi over 3, there's a pi over 3 between each asymptote. Okay, now this 2 here tells me how steep it is. Okay, if it's small, it's going to look like this, like if it's 1/2 or 1/4 or 1/8 or whatever. And if this number gets bigger, we're more like this. Okay, so we're going to cross right between my 2 asymptotes. So I'm going to cross my x-axis here and here. And an easy way to do this is this right here. If you find halfway between where it crosses and the asymptote, okay, it's at 2, so this would be right here, okay, at 2. Or it'd be down 2, so this would be how steep it is. Okay, and same thing over here. If we go halfway from the middle to our asymptote, and then I go up, in this case 2, it'd be right here, oops, right here. And then if I go down, it would be 1, 2 right there. So it would look like this, okay? And I only have to graph 2 periods, so this is all that I need. All right, let's look at example 1b, okay? This is just like 1a. So I want to graph 2 periods, and in this case, we have tangent of 1/2 x, okay? Now, describe the graph. Well, all we have is the 1/2, and the 1/2 is a horizontal stretch by a scale factor of 2. Okay, that should be a review for you guys. Okay, now to find my period, I want pi over b, and remember this is my b value. So my period can be found by taking pi over 1/2. Now remember, when you divide by a fraction, it's the same as multiplying by the reciprocal. So the reciprocal of 1/2 is 2/1. Now, if you want to make this pi over 1, some people find that easier, that's fine, which is 2 pi. Okay, so my period is 2 pi. That means there's 2 pi between each of the asymptotes. Okay, now to find my vertical asymptotes, this is going to be pi over 2 absolute value of b, which is pi over 2 times 1/2, which is pi over 1, which is just pi. So my vertical asymptotes are going to be pi, okay, and then every odd one, multiply the odds, so pi, and then 3 pi, 5 pi. Another way you can think of this is if I have vertical asymptote at pi, so let this be pi over 2, this be pi, this would be 2 pi, this would be 3 pi, so let's do it that way. If you want to think of it this way, if I have a vertical asymptote at pi, and then I have a period of 2 pi, right, I would have another one right here. Okay, now if I need 2 periods, I probably need another one, 2, 3, 4, right here at negative pi. Okay, so now I can graph this. I'm going to cross right here between my 2 asymptotes. Okay, and the 1/2 means if I go halfway between where I cross and here, I'm going to be at a 1/2 here. And I'm going to be at a 1/2 here. So this one's pretty flat. Okay, goes something like that. Okay, it's not nearly as long as my other one. And there we go. There's our 2 period. All right, if you feel like you want another go around before you start in on homework, go ahead and try this one on your own, and then I'll go over the answers. All right, now here's what you should have gotten for this.